So this video, we're going to do a little review of some bonds, but mainly, this video is mainly on two bonds that tons of students get screwed up. Polar bond and nonpolar bond. Then we're going to talk about polar molecules and nonpolar molecules. But before we do that, we'll do a little review. You can't get these bonds mixed up. So the first bond that we took two videos for is this one. Ionic bond. And remember, this is so easy. It's a metal bonded to something else. So it can be a metal to a nonmetal, a metal to a polyatomic ion, or a metallic hydride, which means group 1 or 2 metals bonded to hydrogen. That's it. So if it doesn't have a metal in it, it's not ionic. There's some exceptions, but we're not going to talk about them in high school chemistry. So, ionic bond, metal hooked to something else. Total transfer. They're not sharing, all right? The next bond is this. A metallic bond. It's just a metal. It's not hooked to anything. So it looks like this. It could be Mg with an S there for solid. Or, same thing, Mg with a neutral sign up there. So that's it. This is a metallic bond. The only thing you have to know about a metallic bond, it got free electrons. The free electrons are moving throughout the crystal, throughout the fixed crystal. So that's ionic and metallic. So if there's no metal in this substance, it can't be ionic and it can't be metallic. So the deal is, if there's no metal in it, chances are it's going to be two nonmetals hooked together. And two nonmetals, like we did in the last video, one can't rip off the other. So if it's two nonmetals, they have to share electron pairs. And some share equally, and some don't share equally. And that's what we're going to talk about right now. So we're going to go back over the two types of covalent bonds that we're going to do today. Now, there's two ways to share. Remember, covalent means cooperate between valence electrons. And it's always between, almost always between two nonmetals. And now look, everybody, when we breathe in this. O2 and N2. About 70% that, about 25% that. Do you see any metals in there? No. So those O2, the O and the O and the N and the N, can't be bonded by ionic or metallic. Now, when we exhale O2, some N2, but we do these two, CO2 and H2O. Do you see any metals in CO2 and H2O? No. So what that means is, chances are, they have covalent bonds in them. So if there's no metal in it, and it's two nonmetals hooked together, chances are it's going to be a covalent bond. Okay, so we're going to go over the first type of covalent bond like we did in the last video. The first type of covalent bond is this. This is number 1. Polar bond. A. The reason it's called polar bond is because the two nonmetals don't share equally. So the definition of polar bond is this. And the biggie is a polar bond has to be unequal sharing. One pulls harder than the other. So basically, if it's two different nonmetals hooked together, they're going to have different electronegativities. The one with the higher electronegativity is going to pull the shared pair closer to it. So any two nonmetals that are different and are hooked together, chances are it's going to be a polar bond. So why do they call it a polar bond? Well, if one nonmetal pulls harder, that's going to be a slightly negative end for the one that pulls harder. The other end's going to be slightly positive. Well, it's just like the Earth. The Earth has a positive end and a negative end, but they don't call them that. They call it a pole, a North Pole and a South Pole. Well, this, if it has a positive end and a negative end, it's going to have a positive pole and a negative pole. Okay? That's why it's called a polar bond. So let's go over a couple of them, and then we'll go to the other bond. So let's go to letter B. The number one most important substance that contains polar bonds is water. Since most of our bodies are made up of water, and the Earth is covered 70% by oceans and water, let's electron dot. Now watch this. H2O. Now, the H, if you look at the electronegativity, is 2.2. The O is 3.4. Obviously, the O is more electronegative, which means it's going to pull harder for the shared pair. Remember, O can't rip them off because these are two nonmetals, but O is going to pull very hard. So the electro difference here is 1.2. And remember, for ionic, an ionic bond between a metal and something else, the electron difference is normally 1.7 or higher. But this is 1.2. This is pretty strong. So now let's electron dot H2O. We're going to start with O. O is in group 16. Got 6 valence electrons, which is an S2P4. So here's my S2, P1, P2, P3, P4. Okay, now that's oxygen. Now the hydrogens are going to be right here and here. And hydrogen has 1 electron. But remember, oxygen can't steal it, but it's pulling it closer. So here is hydrogen's electron. I'm going to make it an X and an X. So here is a shared pair, and here's a shared pair. Now, the deal is, why are these shared pairs closer to oxygen? Because oxygen is more electronegative. And the more electronegative element, it's going to pull harder. So oxygen is slightly negative. Now in high school chemistry, like I said in the last video, you don't need to know the symbol for slightly, but we're going to write it down. That's slightly negative. Now, which makes the hydrogens slightly positive and slightly positive. Now, we're just talking about the bond. Does O and H, do they share equally? No, they share unequally. So these two bonds, this bond and this bond, if they're sharing unequally, those are polar bonds. Those are polar bonds. And we're going to electron dot water tons of times because it's the most important. Okay? So remember, a polar bond, unequal sharing. All right? And if the two elements are different, it's going to be unequal sharing. Let's do another one. We are going to do PCl3. So P has an electron of 2.2, Cl has an electron of 3.2. It's going to share unequally because the stronger electronegative element is going to pull harder. So this is going to be a polar bond, but let's electron dot it and check it out. So I have Cl, I have P, we'll start with the P, and P is in group 15, so it's got an S2P3, like that. Then I'm going to make a Cl here, a Cl here, and a Cl here. Now, this is a mistake tons of students make. Cl is in group 17. It's got 7 valence electrons around it. So I am going to make them X's. So we got 1, 2, 3, 4, 5, 6, 7, and there's my shared pair. 1, 2, 3, 4, 5, 6, 7. There's my shared pair. 1, 2, 3, 4, 5, 6, 7. There's my shared pair. Now, if you look at the electronegativities, Cl is pulling harder. So what that means is the pairs of electrons are closer to chlorine. And if the pairs of electrons are closer to chlorine, that means the chlorines are slightly negative. And the P is slightly positive. But once again, to have a polar bond, all you need to do is look at the two nonmetals. If they have different electronegativities, one's going to pull harder. That's a polar bond. All right? Another one. Let's go with this one. CH4. So, carbon is 2.6, hydrogen is 2.2, for a total of 0.4. But as you see, I don't care what two nonmetals are hooked together, if they have different electrodes, it's unequal sharing, it's a polar bond. So here we have another polar bond. So let's electron dot this one. And don't forget, carbon is very weird because it should be this, an S2P2, but it's not like that. Remember, one of the S electrons drops down into the 9 o'clock spot. So we have this. So we have single, 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 single. The H's are all around that. H, 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 H. Their electron, since carbon is a little bit stronger, not much, the pair is slightly pulled by the carbon, slightly closer to the carbon. So which means that the carbon is going to be slightly negative, while the hydrogens are going to be slightly positive. Now, all we're talking about is polar bonds. So I didn't even have to electron dot that to show that this is going to be a polar bond, because these are two nonmetals, the electrodes are different, carbon's going to pull harder, so it's going to be a polar bond. So polar bonds, two nonmetals, whichever one is stronger electrode, going to pull harder, so you have a slightly negative end, slightly positive end, all right? So it's a polar bond. Now let's talk about the other type of covalent. The other type of covalent is this. Nonpolar bond. Well, the reason I like chemistry is because it's always opposites. So if polar bond is unequal sharing, nonpolar bond must mean equal sharing. And this is the easiest bond, nonpolar bond, because there are only 7 examples. That's it. Nonpolar bond. So here's the definition. Equal sharing between So look at this. Equal sharing between diatomic gas atoms. Not between the molecules of diatomic gas, between the atoms that make up. We are inhaling 2 of the most important substances that have nonpolar bonds. O2 and N2. Okay? So, look at the biggie here is a nonpolar bond, equal sharing. So we have 2 types of bonds so far. Polar is unequal sharing between 2 different. Nonpolar is equal sharing, and there's only 7 examples. And here are the 7 examples. Let's put down number 2. The 7 examples, I have my kids remember them this way. NO-17-H. So what that means is these are the diatomic gases. We have N2, O2, group 17, F2, Cl2, Br2, I2, and H, H2. So N2, O2, F2, Cl2, Br2, I2, H2. Those are the only examples of equal sharing. That's it. That's why this nonpolar bond is so easy. Nonpolar bond, equal sharing, only the diatomic gases. Only 7 examples. So let's electron dot a couple of these for number 3. All right, so let's electron dot. What we need the most is O2. So we're going to electron dot O2. So I'm going to put an O here. I'm going to put an O here. Now remember, they got to share equally. O is in group 16. That means each O has 6 valence electrons. So let's put that down. Since they're the same element, I'm going to make the electrons all X's. So we're going to make them like this. Pair, pair, single, single. Pair, pair, single, single. So now, that pair is shared equally, so is this one. So what this whole thing looks like now is this. O, 2 bonds, O. So this is the quick way of writing O2. But you notice one O can't pull harder than the other O. So O2, equal sharing, gotta be a nonpolar bond. It has to be nonpolar because it's a diatomic gas. This oxygen can't pull harder than that one. All right, that's one example. Now let's go to some harder examples. But remember, all the examples I'm going to show you are going to be diatomic gases. You just have to line up the singles to match the other singles. So now watch this one. N and N. N2. 70% of the air we breathe is N2. All right, N is in group 15, 5 valence electrons, but remember, you got to match singles with singles. So let's put, you have a pair and 3 singles. Let's put the pair on the outside. Single, single, single. Pair on the outside, single, single, single. So this shared pair is shared equally, shared pair equally, shared pair equally. So what this looks like is this. N, triple bond N. Remember, one can't pull harder than the other one. So that is a nonpolar bond because it's equal sharing. One more. H, and H. Now, hydrogens in group 1 only got one valence electron. So I have one here, and then this shared pair is shared equally, so it will be H dash H. That's hydrogen. So, one more time. If they ask for what substance has a polar bond, it's just two different nonmetals. If they ask for which one has a nonpolar bond, that means equal sharing, and the only substances that share equally are the diatomic gases. That's why nonpolar bond is so easy. It's just the diatomic gases. All right, now, the next thing we're going to do is we already did polar bonds and nonpolar bonds. Now we have to talk about, is the molecule a polar molecule or is it a nonpolar molecule? Okay, so now I'm going to put down polar molecule. And here's how you tell. If the polar molecule is asymmetrical, you know what that means? And it's really asymmetrical charge distribution. But for high school chemistry, if you can figure out if the molecule is asymmetrical or symmetrical, you got it taken care of. So, polar molecule. So for a polar molecule, it has to have an asymmetrical shape. So we're going to do a couple of them. All right, we'll do a couple and see if they have an asymmetrical shape. So this will be number 1 underneath polar. Polar molecule. Well, we're going to do this one again. H2O. And since we did this previously, you know the O is going to pull harder than the H's are. So we're going to have this. We're going to have an O. We're going to have 2 pairs and 2 singles. We're going to have the H's right here. And don't forget, since the O is more electronegative, the pair is going to be closer to the O. So the O is going to be slightly negative. The H's are going to be slightly positive. Now, we know it's unequal sharing, so it's definitely got a polar bond. These 2 bonds are polar. We know because this and this, the electronegativities are different. But is the molecule a polar molecule or a nonpolar molecule? Well, the definition of a polar molecule is asymmetrical. So let's see. If I cut this molecule right down the middle like this, it looks the same on both sides. But if I cut the molecule this way, doesn't look the same because down here it's got an H, up here it doesn't. So this molecule, the water molecule, is asymmetrical. So the water molecule is a polar molecule. So water has polar bonds because it's unequal sharing, and since it's asymmetrical, it's a polar molecule. So water, polar bond, polar molecule. Let's do a few more. That's an important one, water. All right. And we already drew this one, but we're going to draw one before we do. So let's do this one. Let's do NH3. Well, N is more electronegative than H, okay? So if that is more electronegative than that, we know it's going to be a polar bond, which is unequal sharing. So let's do it. So we have an N, and then we have a pair there, single, single, single. Then we're going to put the H's around it. H, H, H. And then we're going to see that the pair of shared electrons is closer to N. Well, why would that be? Because N has a stronger electronegativity than H. So the pairs are going to be closer to that. So this is going to be slightly negative. This is going to be slightly positive, slightly positive, slightly positive. So we know for sure, even before we electron dotted that, two different nonmetals, going to be a polar bond. But now we have to see if the molecule is going to be symmetrical or asymmetrical. Well, if I cut it straight down like that, it looks the same on both sides. But if I cut it this way, it doesn't look the same. So we know that NH3 is a polar molecule. So NH3 is a polar molecule, H2O is a polar molecule. We'll do one more of these, then we're going to mix it up a little bit. Now, the next one we're going to do is this one. HBr. Well, if you look at your electronegativity chart, Br is stronger than H. So we know that these are two different nonmetals. It's going to be a polar bond in there, unequal sharing. So let's draw Br. Br is in group 17. That means 7 valence electrons. Pair, 1, 2, 3, 4, 5. And then we're going to have the H right here. And since bromine is stronger than that, the shared pair of electrons is going to be closer to bromine. But we already said it got to be a polar bond. How come it's not ionic? There is no metal up there. Can't be ionic. Can't be metallic. So it's not sharing equally, so it's got to be a polar bond. Now let's see if it's symmetrical or asymmetrical. This is a very easy one. If I cut it right down the middle, does it look the same on both sides? Absolutely not. So HBr is a polar molecule. All right? Now we go to some different ones. Now what we're going to do is we're going to do one that we electron dotted a little while ago. CH4. Now, CH4, remember, the electronegativity is about 2.6, 2.2, so the difference is 0.4. So we know that carbon pulls a little bit harder on the pairs than hydrogen, so this thing has polar bonds because it's unequal sharing. But now we got to draw it and see if it's symmetrical or asymmetrical. So now, carbon, 1, 2, 3, 4. Hydrogens, 1 here, 1 here, 1 here, and 1 here. Hydrogen's electron, it's a little bit, the shared pair is a little bit closer to carbon, just a little bit, because carbon's more electronegative. So now what we know is carbon is slightly negative, the hydrogens are positive, slightly positive, slightly positive, slightly positive. Now, we know that CH4, these are all polar bonds, unequal sharing. But is the molecule polar or nonpolar? Remember what I said, in order to be a polar molecule, it's got to be asymmetrical. If it's a nonpolar molecule, it's going to be symmetrical. So let's see. So what we got to do is we got to cut it a whole bunch of ways and see. If we cut it this way, it looks the same on both sides. If we cut it this way, it looks the same on both sides. If we cut it this way, it looks the same. This way, it looks the same. So what type of molecule is CH4? We know it has polar bonds in there, but This molecule, CH4, is symmetrical. So let's write this down. CH4. CH4 contains polar bonds. But the molecule is symmetrical. The molecule is symmetrical. So CH4 is a non-polar molecule. CH4, non-polar molecule. That's the first example. And remember, got polar bonds because it's unequal sharing. But since it's symmetrical, it's a non-polar molecule. Another one. Let's do one that we did before. Well, let's do a different one. Let's do this one. F2. First of all, F2, diatomic gas. What do we know about diatomic gases? Can one F pull harder than the other F? No. So F2 is a diatomic gas, and we said it's equal sharing. So the diatomic gases are equal sharing. That means it's a non-polar bond. But now let's see if it's a polar molecule or a non-polar molecule. So, electrons, pair, 3 pairs and 1 single, because it's in group 17, which means it has 7 valence electrons. So the F's share equally, so we know that that's a non-polar bond. Now, that's a non-polar bond, but let's see if it's a non-polar molecule or a polar molecule. Remember how we're going to tell? If we cut it, let's cut it this way. It looks the same on both sides. Let's cut it this way. It looks the same on both sides. So what do we know about F2? It has a non-polar bond because it's equal sharing, but since it's symmetrical, it's a non-polar molecule. So F2 equals non-polar molecule. So the big deal between polar bond and non-polar bond. Again, polar bond is unequal sharing between 2 nonmetals. Non-polar bond, equal sharing, and it has to be example of a diatomic gas, like that one. Polar molecule, it's got to have an asymmetrical shape, like H2O or NH3. Non-polar molecule, it has to be symmetrical shape, like F2. So, here's another rule. We're going to write this down later. If the substance has polar bonds, it can be symmetrical or asymmetrical. So in other words, if it has polar bonds, it could be a polar molecule if it's asymmetrical, or it could be a non-polar molecule if it's symmetrical. If it has non-polar bonds, and remember the only example of non-polar bonds is diatomic gases. So if the molecule has non-polar bonds, it must be a non-polar molecule. Now, this is the part that a lot of students screw up in. So what we've gone over today is this. What's a polar bond? What's a nonpolar bond? What's a polar molecule? What's a nonpolar molecule? And we're going to go over a little bit more of that in the next video also.